Hi guys, I know it's been a while since I made a video. I've been kind of busy lately, being summer and stuff, and doing a lot of stuff outside. So anyway, the other day I was cruising along on Craigslist and I found an ad on there. So I thought I'd show you some of the stuff I got. I will tell you that each individual item I'll do an individual video on later. They all need to have some work done to them, to check them out, probably some recapping and stuff. But start off with, we're going to come over across here and kind of zoom in a little bit. Not too much. What that is Panoramic ultrasonic spectrum analyzer, made by Singer. It was on a Navy ship. I imagine what they used it for was working on probably sonar equipment along with a few other things, sounding equipment and stuff. At this point in time, I don't have a lot of information on it. Can't find any service information. The model number on it is an SB15A. It's rack mount, but it does work. But it does have at least one electrolytic I know that needs to be replaced in it. It's getting a little warm after it's on for just a little bit. I can't find service information on it or even operation information, although most of it's pretty straightforward. But there is a model that was contemporary to this. This goes up to 600 kilocycles. The other one that's a sister model to it starts off at that point and goes on up to around 25 megacycles. The circuitry appears to be quite similar. I know the power supply is exactly the same. That's the only thing I've actually looked at real close. Basically, I think all they did was when they wanted to change frequencies, there's 4 crystals in it that need to be changed. And you can change the frequency that it actually operates on or receives. Basically, a spectrum analyzer is like oscilloscope, except instead of looking at voltage versus time, you're looking at some sort of amplitude. Can be voltage, can be other types, amplitude such as dB or whatever, versus frequency. And you sweep that frequency, and you can look at band pass, filters, and things of this nature. You can also look at even signal outputs, such as like a transmitter or something of this nature that produces a signal, and look at them, see if they have harmonics, check out their band pass and stuff of that nature, and any other associated distortion or anything in the signal. I got it mainly because it was reasonable price, but going up to 600 kilocycles, I can actually use it on checking bandpass filters on IFs in the broadcast band range. Those run like 455, 460, 465, or 470, or even lower. And so I could actually use it on that. When I do get to it and decide to, go in there and replace electrolytics, I'll do a further video on it. Hopefully I can find some service information. Otherwise, it'll just be, since it was part of in the Navy, a military piece of equipment, I'm pretty sure that any work was done on it was done in a proper order. In other words, replacing components with exact values that is according to the service information and what was in it. So anyway, that's one piece of equipment I got. And we'll rotate up and come up a little bit to this nice little piece of thing. Now, focus. I don't know if it's going to focus. I may have to raise the camera up to do this. There we go. Now what that little thing is, and I'll move the cables out of the way so you can see it a little better, and we'll look at them here after a bit. That here is a Hewlett-Packard model 410 BR vacuum tube voltmeter. It's the predecessor to the 410C that a lot of people talk about, HP 410C, which came out after this sometime in the 70s. This was introduced in the early 50s, around 1952, and they kept it producing it up through into the early 70s anyway, when they brought the 410C out. It basically is got the same specs as the 410C for all practical purposes and operates in the same way. We have resistance that measures resistance from 0 to 500 megs, and then they have a way of, in the manual, telling you how you can go much above that with an external voltage source. It also measures DC volts from, well, 0 volts up to 1,000 volts, and AC volts from 0 volts to 300 volts. Now the unique thing about it, it has no internal battery for the DC, or for the ohms, excuse me. The ohms is where it gets power as off the filament winding on the transformer. They rectify it and supply it, so that's where it's getting its power. Another unique thing about the Hewlett-Packard 400 series was the very high input impedance. This one actually on DC has 122 megabyte or mega ohm input impedance, as opposed to like my flute digital meter or a lot of other standard VTVMs of having 10 to 11 meg ohms. This is 122 meg ohms. The other thing is AC actually uses a special probe. We'll look at it. It came with it, but it's a rectifier. It has a rectifier diode tube in it, and it's high frequency. Basically, it has a flat level on the curve from DC all the way through 500 megahertz. Will easily measure up to 700 megahertz and actually above that. In fact, the diode tube is good to 3,000 megahertz. And according to the HP, this thing is perfectly good going up to over 1.2 gigahertz measurement. So you not only measure an AC, but you can measure very high frequency AC. Now, the probe, and well, before I get to the probe, this has a unique little bit of history where it came from. The guy who had it had cut the case down a little bit, the faceplate. This it's 410 model 410BR, which is the same thing as the 410B, except for the R is rack mount. So, and I'll show you a picture of what it should look like. If you kind of memorize what you're seeing here, we'll kind of rotate around. I'll zoom back out a little bit, and we'll rotate around slowly to the screen. And that's what it should look like. So, excuse me. It had been cut off right here, and right here. So we took the ears off. This is the plug for the leads. He had moved that underneath and made a bracket fit on so that it can plug in, and cut it off. Took the casing that was on it and reshaped it and cut it down, and along this, the front plate is like a 1/4 inch aluminum. He drilled holes in it and threaded it, and then he took that aluminum plate and sized it around to fit on there good and tight, and then he used flathead Phillips screws, which he recessed down some, countersunk down, so that the surface is nice and flat. Did a real nice job on it. What the B looks like is like this. It's basically the same thing, same front panel, except we rotate this 90 degrees. We rotate the numbers on here 90 degrees, rotate the meter 90 degrees, and then they put the plug in underneath. So same orientation on the controls and stuff. The only difference is this is for a rack and this is for a desktop, and that's what he wanted. He wanted a desktop. Now we'll come back, we'll look at the probe a little bit, the main probe. All the rest of them are pretty much standard. So come back here. And I suppose, well, we'll look at some of this other stuff I got too after we look at the probe. So this is the AC probe here. You have a ground clip, and then the reason for the size, and I'll show you, is we can unscrew this here and pull it out. There's a little diode tube, rectifier tube, 2-01C, and that's what it looks like inside. Now up in this tip, if I set this down, which unscrews also, we'll pull that out. Inside here, right down inside there, that big round piece is a ceramic capacitor. There's a capacitor in the tip, and then there's a resistor that goes from here through this plastic. It's embedded in this plastic and goes and makes a connection inside. I don't know if you can see that. I'll try to show it to you. Get something to point with. Right down in there, you can see the kind of where it was soldered. It's kind of hard to see, but it's embedded in the plastic here. That's a 22 meg ohm resistor, and then inside this part, this little piece right here, if I can get it, you can kind of see a little looks like something circular it's hooked to. It's a 500 picofarad capacitor that is connected to. So several components already in this thing, and some of them you have to actually buy the whole probe. It would be very difficult to ever get them out of there, like if they were bad. I already measured the resistance on the 22 meg, measures right on the money. So I assume the capacitors are probably good too. But that is the AC probe that you would use. This outer shell here, what this ground hooks to, is the same ground as the main common ground. They just use a shorter lead, especially when you're using high frequency. You don't want measuring high frequency. You don't want real long leads because it can cause you problems. Now, we'll talk more about this thing because, like I say, I've got to work on it too. I want to check. It needs some calibration. I want to check the resistors in it, as well as the electrolytic that's in there, filter cap. Now, some other stuff. Well, we'll get to it in a minute. And we're going to move the camera over just a little bit. This is another piece of equipment I got. And Tektronix type 317 oscilloscope. Got a little 3-inch screen and kind of nice little scope. It's 10 megahertz. It's from about 1958 or 59. Unique thing on it, at the time when it was made, it's a portable scope. It's got a handle. Weighs in probably about 40 pounds, but they considered that portable. But when this was made, it's a sister scope to the 316. The only real major difference between the 316 and 317 is the 316 used a lot lower voltage for the anode voltage, accelerator voltage for the tube. Ran at about 1.5 kilovolts, where the 317 runs at 9 kilovolts. They did that so you didn't need a hood. It was nice and bright. But as you can see, this one has a little problem. It's got burn-in, and although it doesn't seem, there's actually 2 lines of burn-in, but it doesn't seem to be affecting it. Excuse me. You can actually see it real good even when it goes through the burn-in. It still produces some light. But this all came, there's a lot of all this stuff I'm going to show you came from one collection. A guy that's moving out of the state, moving to Arizona because of health reasons, and he is downsizing tremendously because he doesn't want to move all the stuff. So he does have, I was told that he has several tubes, but also some new old stock CRT tubes. And so my guess is he probably bought one for this at one point in time and just never got around putting it in there. So I'll probably see about getting that to replace the one in here. Otherwise it does actually work. Now the unit does have a few little problems. Trying to get the vertical to come down centered by adjusting the control down here. You have to turn it fully counterclockwise and then take the calibration and take it out of calibration on the vertical amp and move it some to even get it close to center. So there's an imbalance in there. So that'll be one troubleshooting thing that we'll go through when I get to this. The other thing too is after it's on for a little bit, when I try to reduce the illumination on the screen, I should be able to take it to 0, but after it's on for, say 25 minutes or so, 30 minutes, it gets where you can't do that. You can really brighten it up, but you still have you can still plenty see a trace going across there at minimum intensity. So there's a problem in that circuit as well. Be the I believe it's on the grid bias is off some, or floating off, probably a resistor or capacitor or both. So here in a minute I will open it up and show you, but first I want to show a couple other little things that I got. One thing is this guy is a Hackle Ace model number 481 desoldering pump tool. It sucks the solder into here when you hit the button. It's only got one problem I still got to try to source, is the heating element is bad in it. And if I can find one, then it'll be perfect good order. The pump works good and has good suction to it, but right now the heating element is not heating up. The wires have come loose on it. The other thing was in our high voltage probe made by Heathkit. Seems to work fine. I've tested it and it seems to be accurate and stuff. So the thing I like about this, the other ones I've got plug into a meter, and this is standalone. So you just hook up to ground, probe into your high voltage, flip it on, and read it directly. It goes up to 40 kV. And that was basically just thrown in with the lot. The other thing was a whole pot full of doorknob caps, various different styles, going up to, this is a 500 picofarad at 30 kV. Several of them are 500s at 20 kV. Some are used, some might not have been used, but they should be alright. Even a couple oil filled 3.01 microfarad 300 working volts, or 3000 working volts, 3 kV. So a lot of doorknobs, and then a lot of pretty much new old stock high voltage ceramic disc caps. Most of them are I believe, I can't see that one too well. I think most around 12. Yeah, 6 kV, 6 and 7 kV in there. So those were kind of just thrown in with the lot. So I'm going to pause this and get the scope moved around so we can take a little closer look at it, and then that'll be probably where we'll end the video at. So I'll be back in a sec. Okay, I moved the scope around a little bit. I'm going to open the side up. These Tektronix back in the day was pretty easy to work with. Now it's missing one of the screws here, but we do have the cam, which I don't think you can probably see right here. I'll show what that is. I want to get the side off, but you basically just give it a little bit of turn and pull it out. Now that little plastic piece I was showing you is this piece here and stuff. So really basically what I'm missing is just the screw. So I just got to get a screw to fit it, and I'll have it. But this is the insides of the scope. Several tubes on this side, more on the other side. Over in here is the vertical circuitry, vertical amp, and deflection system and everything. This also then in turn feeds out of here and feeds into this, which is kind of hard to deal with, up through in here and here. And what this is the delay line, and it's basically made up, and I'll try to zoom in on them, rotate you around a little more. Alright, focus. But what they are is several coils and capacitors going across the coils, one coil for each side of the line. There would be two sets, and capacitors going across, several of them going up and all the way around here and to here. They feed through a couple resistors and come down here to the vertical deflection. And you can actually slow current down. In fact, resistance by itself slows current down in a circuit. But this is making use of, well, there's some DC resistance in the coils, but more importantly, it's making use of the inductance and the capacitance and that total impedance to slow the signal down coming up through. So that's called the delay line. Now, I seen a video of someone talking about a Tektronix scope. I have not actually said anything to them or made a comment, so I'm not going to mention who it was. But they mistook that and not called that the delay line. They actually showed some tubes and said they were the delay line. No, they don't use tubes for delay line. They use this type of principle. Basically, it's impedance is what they're doing. So we'll widen back out and take this thing around and show you the other side. And of course the bottom comes off too. There's a lot more circuitry in there. I'm going to move us a little closer here and zoom in to the top part. And I'm going to lift you up a little bit so we can kind of look down on it. So bear with me. And rotate this around. Okay, let's come in here a little closer. So this is how Tektronix back in the day, instead of having a standard terminal strip like you would see, something like this, like you'd see in most radios and TVs, they use these ceramic standoffs, and then they had little cut into them, or actually formed into them, were little U-shaped places in them, kind of like cutouts. And then the metal that you see in there, and I keep losing my pointer, but this metal in here is silver. So when you actually work on these, if you ever get one and you need to replace a component or two, you want to use silver solder and a relatively low temperature. So really basically modern day solder that you get for modern day lead free electronic stuff is silver bearing, just like this stuff here. So, and the reason is lead solder kind of reacts a little bit with the glue that holds the silver in here, but also the extra temperature usually lead solder requires over silver solder. According to the manual, you can, if you're just replacing a component once, you can use either one, it's fine. But if you're going to be in here actually doing a lot of work, or replacing for whatever reasons a component quite often, or several of them, then it's best to use the silver solder and keep the temperature low, just above the melting point, so that you don't break these loose and get them loose from there. So the old girl does need some work. I'm sure there's some of the resistors are probably off, at least some of the carbon comp resistors, plus all the switches in this thing are pretty dirty, so I'm gonna have to clean those up, spray a little contact cleaner on them and get them cleaned up. Now we're going to kind of lower down and look at the insides here a little closer. Now starting over here, we have one filter cap, and then back in here we got some more caps, electrolytics, all the way back in here, and these probably all should be replaced. If not, you know, it seems to be working all right. This guy over here is the main filter, and he wasn't getting warm, so when I had it running, and they did use good quality components, but still it may not. I'll probably go ahead and restuff the cams at some point. They're not that difficult to get to. You pull the bottom off and you can get to the bottom of them pretty easy. This one here would be the tightest one, not so much from the bottom, but there's still enough clearance here by the fan to get it out. Fan works good, runs good. Of course, it's like any fan, it's not the quietest thing in the world. Some of the controls are dirty, as well as the switches, so they'll need some contact cleaner to get them up in good shape. But that's basically all there is to it. One interesting thing to note on this, and I want to answer somebody's question as well in the comments. I'm sorry I haven't got to anybody's questions in the comments or anything, but it's been kind of hectic and busy. There's something I want to show here. If I get this thing rotated around, and I probably can't lower this anymore, but maybe you can kind of read it. It says CRT cathode, and over here it says ground. You notice that this has got a clip going between these two, and that one's pretty tight. But anyway, this should stay closed all the time. Well, this thing here is doing exactly the same thing as what I was talking about on that TV that I've been working on. Stromberg Carlson, they have in the power switch where you shut the power off, it would then ground the cathode on the picture tube. And we talked about that a little bit to stop the dot showing up on the screen after you shut the power off and possibly burning a hole in the screen. That's what that's there for. The circuitry is designed such, and when we start working on this, I'll show this a little more in schematic and how it's hooked up, but such that when you shut the scope off, this bleeds off the cathode by hooking the ground like this, and it states it should be, you know, you can leave it in place, and it's supposed to stay in place, and the thing works just fine with that being in there. But and the question I want to answer was by grounding the cathode, does that take the charge off the picture tube? And I'm assuming the charge on the picture tube is the charge on the anode, the accelerator anode, or actually in the capacitor that's made up by the picture tube bell. You know, you've got aquadag on the inside of the picture tube for the accelerating anode, and then aquadag on the outside. Well, that's two conductive coatings with glass insulator between them to make up a capacitor. If you turn the TV on, if you got high voltage, it'll charge up that picture tube there, and when you shut it off, it'll stay charged for a good week anyway, unless you discharge it. And even after you discharge it, it can rebuild up some on its own for memory effect. But no, by doing this here, or the same thing Stromberg Carlson was doing by just switching it off, ground the cathode won't have no effect on that capacitance that's on the bell of the picture tube. That charge will stay there. You have to take a screwdriver, hook clip lead to it, hook it to ground, and stick it up underneath the anode cap and discharge that, as well as if it has a doorknob cap. But it won't discharge by this cathode. There's no direct connection. So anyway, I think that's about it. I suppose I ought to answer a couple other questions while I'm on that. we'll just keep looking at this while I'm answering them. And so the other question was just talking about cadmium oxide and how to get rid of it and stuff. And what it is. Well, cadmium oxide is just that, cadmium oxide. You got a cadmium plating that some equipment used, and the plating's on there to protect the steel. But it's sacrificial, meaning that it's okay for it to corrode a little bit. And under normal circumstances, cadmium, when it's brand new, when it's first plated onto a chassis, it is almost like chrome. I mean, it's real shiny, very reflective. It's kind of difficult to tell the difference between it and chrome. But in short order, well, in a little bit, it starts kind of getting more of like a dull color, kind of like unpolished aluminum color, or kind of something of that nature. And that's normal. That's actually the first beginnings of the oxide. Now, as long as the item is kept in a decent controlled environment, not too much humidity or acidity in the air or anything like this, that's as far as it'll go for many years. It won't change anything more than that. But if it's been in a rough, not very good environment over the last, umpteen years, then it can develop some what appears to be white powder on it. That's cadmium oxide. If it's greenish yellowish color, then that's cadmium sulfide, and it's a little different. But when to get that state, it's been in a bad environment and stuff. It's high humidity, maybe some chemicals in the air, acidity in the air, or maybe in some places it might have been electrolytic, also leaked out some of its guts on cadmium and caused it to accelerate in oxidation. So how do you get rid of it? Well, if it's just the powder that's on there, you can actually just wipe it off. And for the most part, you asked if we could use a damp paper towel to clean it off. Yeah, that's fine. Or use some little household cleaner with it or something, and just wipe it off. Now, that's not going to get all the oxide off, but what you can do then at that point, you can take a metal polish, something like Simichrome, something like, get in the camera, there we go, and put a little bit on there and polish it. That will clean off the rest of the oxide and shine it up. Or if you don't want to go that route, various rust removers like navel jelly or Rust-Oleum, rust stripper. This stuff here is pretty strong. You want to dilute it with at least 50-50 with water. The navel jelly, you could dilute it a little bit. Either way, don't leave them on very long. You're only wanting to kind of clean the oxide off. So you just kind of put them on there, wait 30 seconds or so, and then just wipe them off with a paper towel or something. Dampen one, wipe a couple, 3 times. That'll neutralize the acid or dilute it down real good, and then you can just dry it off. Now, as far as protecting it, keeping it from oxide, if it's kept in, say, it's in your home, assuming that you got, you keep your home kind of steady temperature, air conditioning in the summer, of course heat in the winter, you probably don't have to do anything. It would probably it'll stay in excellent condition for as long as you want it to. But if you're really concerned about, there's many different treatments that you can do, anywhere from just WD-40 spray on there a little bit and wipe most of it off and leave the thin film. There's rust inhibitor treatments that are generally a wax oil mix, like petroleum oil mix with wax in them. You can even use just car wax and put it on there, because it's got an antioxidant in it, keep any oxygen from getting to to paint normally on your car paint. Or you can hit it with some clear coat of some sort, like enamel or lacquer for metal. Or just leave it alone and see how long it does. Now, if the environment's good, you can just leave it alone after you've got it cleaned off. A year later, look in there, and if it's still looking good, then probably it's not going to give you any trouble. Now, eventually it will dull, kind of like this aluminum is here and here. Instead of being shiny, kind of like chrome up here. That's normal. That's the oxide level layer getting on there, and what that does is actually protect the cadmium. And it should not go any more than that. But if you start seeing it repowder up again, you can clean it off again, and then use something to protect it. One last thing I wanted to say was someone else gave me a comment saying something about he's getting started and got his first radio, a 50s radio, probably I imagine an All-American 5 or something. He didn't say for sure. He suspects that he's got to replace the capacitors in it, which, yeah, at least the paper and any paper caps in there and electrolytics. But he did mention in there that he's waiting to test them. He's waiting for an ESR meter. Don't trust ESR meter with this type of stuff. Tube equipment, the capacitors in those, electrolytics are generally high voltage. All-American 5 radio would be like rated at 150 volts. Something that's got a transformer in it, like this thing does, probably looking at, 2, 3, 450 volts or more. So ESR meter is not going to tell you anything when it comes to these style caps. It's designed for general electrolytics used in modern day electronics, generally high frequency, such as a switch mode power supply caps. They're low voltage, and the unit actually subjects them to general frequencies of what they would be seeing in that switch mode power supply. They can actually read good, like this. These type could read good on the ESR meter, but actually be quite leaky. So what you really want is something like this thing right here, and I'll move these leads out of the way to let you see it, and a little better. But I really hate that when the batteries go dead right in mid-sentence. But anyway, instead of ESR meter, you want something like this. This is a resistance capacitance comparator bridge. It's an ICO model 950B. It's designed to test capacitors and resistors. But the big thing is it's designed for checking leakage up to 500 volts as well on both electrolytics and paper, mica, ceramic. You can also test. So, and you don't have to get an ICO. Knight made one, or a couple of them. Heathkit did. Some of the capacitor companies did, like Solar. So there's several different ones out there. Probably the most popular ones is on eBay, which you can get these things pretty reasonable, like $30 or something. Is like the ICO, Heathkit, and Knight, because especially ICO and Heathkit was really the big kit companies and stuff. So you want to use something like this on checking leakage on those electrolytics and any of the other caps in there if you're going to want to actually test them instead of an ESR meter. So anyway, I guess that's about it. Again, there'll be videos upcoming eventually on this different equipment and working on it and discussing it and talking about it a little more in depth. So look forward to those. I'll be getting back on the TV. So it's coming in the future. Some more videos on it. And so I think that's about it. I can't think of anything else. So if you really like the video, give it a big thumbs up. And wait, if I can find my thumb. Yeah, there it is. And as well as, you know, comment. If you're new, subscribe. I thank you for the new subscribers on here. So there'll be more videos coming. So thanks again. Thanks for watching. See you on the next video.